The book. Is it to do with Sagittarius A star that she talked about that? I forget. I'm trying to get to the point in the book. Looking at the index here. Give me 1 second. So basically, there is a nice little discussion of how you can dive into a black hole with some strategy. So let's talk about that because it's actually helps to understand it. 462 Sagittarius A star. I wonder if she will. Yes. This is it. Yeah. So whether you will be tidally shredded or not is something that we will discuss when you're going into a black hole. Okay. So the galactic center has this. We talked about it. There is some bright stuff going on from the galactic center. It's a strong radio source, Sagittarius A. They figured out that there is a black hole there. It's called Sagittarius A star. So in this book, they talk about Sagittarius A West and whatnot. And then if we zoom in on the center of Sagittarius A West, we find a highly compact radio source called Sagittarius A star. Once again, that's A with an asterisk, and we call it Sagittarius A star, meaning the supermassive black hole at the center of our galaxy, okay? The angular size of Sagittarius A star has been measured using radio interferometry at a wavelength lambda equal to 7 millimeters. The measured diameter of Sagittarius A star is around 0.8 milliarc second, okay? So that's quite small, corresponding to around 6 astronomical units in physical units, where our distance from the sun is, of course, 1 astronomical units. The high angular resolution provided by radio interferometry also enables a measurement of the proper motion of Sagittarius A star. Measurements reveal directed almost entirely along the plane, blah, blah, blah. Observations by the Chandra X-ray Observatory reveal that Sagittarius A star is an X-ray source as well as a radio source. So I was mentioning how the infalling matter into a black hole will sometimes give off a lot of different radiation in different electromagnetic wavelengths, such as in this case, X-ray, radio waves, etc. Right? The X-ray emission from Sagittarius A star varies significantly on timescales of less than an hour. Wow. Revealing that the majority of its X-ray emission must come from a region less than 1 light hour across, right? Because remember, we are, how many light minutes are we away from the sun, gentlemen and ladies? What is the distance of us from the sun in light years or light hours or light minutes? Somebody put it in the chat. Exactly. Very nice. 8 what? Exactly, 8 minutes. So it takes light 8 minutes to get to us. The variation of X-ray shenanigans with this Sagittarius A star was happening across 1 light hour, which means that that's sort of giving you an idea for the length of this thing. Okay, so let's review what we know about Sagittarius A star. It is a fairly luminous but highly compact source of radio and X-ray emission located at the galactic center. So whoever asked about the black hole, whether there is one at our galactic center or not, this is the answer to that. So there you go. The bolometric luminosity of Sagittarius A star is not exactly known due to the high extinction at many wavelengths, but is estimated to be around 1,000 solar luminosities, okay? The leading hypothesis is that Sagittarius A star is a supermassive black hole that is accreting gas. All of that accretion is making a lot of things fall in with some acceleration and giving off a ton of radiation, okay? A supermassive black hole is a black hole larger than would result from a massive star collapse alone. So this is what I was saying earlier.